Today we're gonna learn about a robot life following in advance. It's different from the previous life following robot that you did from the programming lecture. Okay, firstly I will give you the flowchart, the concept about the advanced life following robot. Okay, and then the bullet number 2, 3, and 4 is views. Actually, the 3 bullet is from the flowchart. Okay, that I show you. Okay, this flowchart will combine everything that you learned before. For the example, it is integrate. This is the integration of the. Do you remember? ADC DMA. Okay, indicate the sensor normalization and PWM. Okay, but from the lecture that you learned before, you use only one channel, right? But for today, you have to, not today, for the project, you have to control two motor. If you have to control two motor, you need two channel. Okay, maybe channel 1 and channel 2. Okay, let's combine the thing that you learn. And also the last one is the last week's is a timer interrupt. The last one is a timer interrupt. Okay, this is a flowchart that used to build a robot. Okay, I will explain you. Okay, firstly, to making the robot. Firstly, to making the robot. Okay, to making the robot. We have to make a robot to following the line, right? We will talk about the component of the robot. Okay, okay. Our tag is a line follow. Okay, the first component is the sensor. For sure, if we have more sensor, it should be more accurate, right? Okay. But the equipment that we have is around 8 infrared sensor, 8 infrared array sensor. Okay, and the second one is the processor. Okay, because we have the number of the sensor is around 8, right? That's why, Okay, we select STM32 to be the processor. Okay, we can measure the light from the sensor. We can process from the processor, and the last one, we have to control. We have to control. So the way that we control, we use the model of the differential drive. What does it mean, the differential drive? For the differential drive, it look like this. This is a robot, and this is a wheel that controllable. Okay, for the differential drive, okay, we call differential drive. For the differential drive, we will have a two wheel. We can control two wheel. Okay, so you can put another wheel that not suited to control, just lowering. Okay, to make a robot stand. Okay, so we use the model of the differential die, so this means we have to control two motor. We have to control two motor. Maybe motor right, and this is a motor left. Okay, this is a component of the robot that we use to make it move, to make it track the line. Okay, component we talk about the hardware, but when we talk about the how to control, okay, how to control, we write the program and upload to the processor, right? Okay, I will explain more about the processor. Processor have to get the information from sensor, right? The way that we use to get the information from the sensor is the ADC and DMA. Okay, ADC and DMA to get the analog value and keep in the DMA because it's very fast, and then okay, we read it into processor, and then do you remember we normalize thing, we try to get the position of the robot compared with the line, and then inside the processor we have to, what we have to do, we have to try to, we have to compensate. What we have to compensate? Error. Okay, we have to compensate the error. So for the example, okay, if you have the line, this line, and your robot is here, two wheel, okay, I can explain that this is the center of the robot, right? Oh, sorry. Okay, this is the center of the robot. Okay, actually, if you measure, you can use the infrared sensor to measure the position of the line, right? Compare with the position of the robot. Compare with the center of the robot, okay? These things between this line we can call set point, okay? Set point is like a target. Target our target is 0 because in the center is 0. Okay, between from the line that we detect and compare with the set point that we need, okay, to control the robot to center the line is the way we will control the robot to move. And what we need the set point or the center of the robot to be in the position of the center of the line. Okay, what we call this thing inside, what we get the error. Okay, we get the error. So these robots, we get the error, right? But if the center of the robot is the position is at the center of the line, so it means it's no error, right? Okay, so the thing that we the concept that we have to do is we have to compensate the error. Okay, so if we have an error, what we have to do, we have to try to compensate to control the robot to move in what position. We should we should speed up this motor, right? And we should slow down, right? We should slow down. Okay, and then we should speed up. This is the thing that we have to do. Okay, to slow down one wheel or the right wheel and speed up the left wheel. Okay, to make the robot to move like this, move like this. Okay, this is a concept. I want everyone to think the same thing and we have the same target. Okay, so for the compensate an error, after that we will have the output. Okay, to control the motor. Okay, for the output from the compensation is a PWM. Okay, is a PWM. So we have two motor, right? So that means we need channel, not A, is channel 1, CH1 and CH2. Okay, you already learned PWM. Okay, you already learned the ADC DMA. Okay, the thing that you have to learn today is how to create the output and the compensation. Okay, so right now we have the output to the channel A and channel 1 and channel 2, sorry. So we can use the channel 1 to control the model left, and you can use the channel 2 to control the model right. Okay, that is the concept that we use to control the robot. Actually, we can use this concept to control everything. We have sensor, we have processor, and we have the control part. Okay, and actually we can say it is an actuator. Okay, it is an actuator. So when you understand the concept of the line following robot and the differential dive, for sure it's different from the programming, because when you learn from the programming, No, nothing. You just know the programming. But right now you know the microprocessor, and you know I will let you to know some the concept about the robot also. Okay. To complete the project, I already make the flowchart. Okay, you can do follow my flowchart. Therefore, my flowchart is the concept to do to make a robot that we need every we need the knowledge from the every chapter that you learned before. Okay, so lastly, you have to think, you have to loop, right? The left hand side is the main program, and the right hand side is the interrupt. Okay, left hand side is the main program, and the right hand side is interrupt. So main program and the interrupt is will work, it will execute simultaneously. Okay, simultaneously, like a multitasking. Okay, why we need interrupt? Why we need the timer interrupt? Because for the timer interrupt, do you remember? You can configure the frequency, right? You can configure the frequency. Okay, that is the main purpose of the timer interrupt because you can configure the frequency. Because the main thing of the control part of the robot is we need the we need the time constraint. Okay, I will show you uh, in the next page about the equation that we use to control the robot. One factor of the equation is the time. Okay, that's why we strict with the sampling time. With the sampling time, because okay, and the timer interrupt, we can control the frequency. We know this this program is will execute every maybe 10 milliseconds. Okay, we know exactly time, but the main program cannot do that. Someone think it can do, but the time is not strict because it's not made to strict like a timer interrupt. Okay, so what we need to do in the main program, we need what we need to do in the main program. For the main program, we need to the task that we did in the main program is a general task like initialize, uh, getting the speed, getting the sensor max or means, uh, we can do some the data communication like you add transmission. We can do in the main loop. Okay, we can do in the main loop. But for the control part, we should do in the timer interrupt because here the time is strict. Okay, we know exactly the processing time. Okay, I will start from the left hand side. That is the main program. Okay, do you remember? Firstly, you have to when you read, when you need the information from the sensor. Okay, you need the information from the analog ADC module, right? Okay, you need it in ADC module, right? So this thing actually you can learn again from the week 11 in the ADC DMA module. Okay, because this week is about the integration to be the robot. Okay, firstly, for the main program, you have to initial ADC DMA for sure. Okay, in the main program, you have to initial everything. Okay, don't forget it. ADCDMA, we use to read the information from the sensor, right? And the second one, the timer interrupt, we use it to be the control. Okay, okay, we use the timer interrupt to execute the control path. Okay, and then initial PWM on the channel 1 and channel 2, we need it to control the motor left and also right. Okay, do you remember initial the module everything? Okay, uh, in the previous lecture and the slide, you have to go to the device configuration and the configs from that. Okay, and then in the program, you have to initial like this. Okay, you can comply allow 3 weeks. Okay, to complete this. And the timer the lab you just learned from the last week, right? Okay, initial sensor min and max for the sensor normalization. Okay, this is from week 11. Okay, the topic about the sensor normalization and positioning. Okay, do you remember that you push the button to try to get a minimum value and a maximum value, and then we try to align, the value of the sensor. Okay, and fit it again. Hmm. So why we have to do, because the characteristic of the sensor is different. You have the X sensor, you measure the same color. Actually, it should return the same result, right? But in real life, if it's not return like that. Okay, some sensor, for the white color, it should be 1000, but it show 800 instead. Okay, that's why uh, we try to normalize to changing from the 800 to be the 1000 again. Okay, we keep every data of every sensor and then we do the normalization. Okay, to make it reliable and more accurate, I think. Okay, this is a loop to getting the information from. This is a loop that you have to do to uh make the sensor sorry, to get the sensor min and max, to get the value of the sensor and keep it in the variable sensor min and sensor max. Okay, because you have to use it when you normalize the sensor. Okay, we need the minimum value of the sensor and we also need the maximum value of the sensor. Okay, this is the thing that you learn from maybe week 10. Okay, maybe week 10. And then after you compete to do this, to get the sensor min and sensor max, okay, it will continue with the while loop. This thing represent this y1. Okay, it represent something like this. In the block diagram, I set linear velocity v linear. Okay, why we have to write something like this? Because we have, do you remember I told you about the control part, right? We will use this one to be the one factor in the control part. So to make a robot move, okay, to make a robot move. If your robot is not, it's not good, okay. This is a robot and you have two wheels, right? So what we can do, the linear velocity means here, okay. So when we want to control the robot in advance, okay, we have to know, we have to command by the linear velocity and also the angular velocity W, okay. Okay, so the block diagram that I show you is related to the thing that I explained you. Okay, we will set the linear velocity. Uh, why we have to set? I will have a, as I told you that we will use the timer interrupt to be the control part, and the timer interrupt will waiting for the linear velocity that we command from the that we command from another task. Okay, if we set linear velocity to greater than 0, that means you commanding the robot to move forward, right? To moving in linear, okay, to moving in linear. So what you have, what we can control, linear velocity, it is an open loop, right? We we give them the like some speed and then it move forward, right? But we don't have the sensor to measure the speed correctly, okay. So we will not do that. But the thing that we have to control is angular, okay, because we need to control the position of the robot, right? Okay, that's why we can control the angular velocity of the robot. Okay, we can control the angular velocity of the robot. Okay, so this thing we just give the robot, okay, constant. We not control, we just give the command. But angular velocity we have to control. Okay, we have to control because we will use the angular velocity to make the robot align the line. Okay, to align the line. Another another routine, another task. Okay, we have a time period elapses callback. Okay, that is a call from the timer interrupt. Okay, it's called from the timer int interrupt. Okay, so we use this to be the control part of the robot. Okay, let's start from the getting the ADC value. Okay, that is like a reading information from the sensor. And the second one is a normalization sensor, the thing that you learned before about the how to make the sensor more accurate. Okay, and then you have to positioning the sensor because we need the real position of the sensor. Okay, and the next step we need the error, right? Okay, this is the related to the thing that I like I teach you before about the this is the robot and then okay this is sensor of the robot and light is here and okay we have to measure between the this is a set point and this is a line. Okay, and inside is the error. Okay, between the line, the center of the robot, and the line of the floor, the position between that is a error. Okay, we have to know the error first. When we know the error, we will calculating something to compensate that error, to eliminate the error. Okay, and then next step, we have the uh, techniques we call PAD control. Okay, we call PAD control. Okay, what happened with my pen? Okay, we have the technique called PAD control. I will explain you next slide. Okay, but lastly, we give the error to the PAD control, and we use the PAD control to compensate the error. What we get from that, we get the output from the PAD controller. Okay, and the output that we get, we will use that one to compensate the robot. Okay, to compensate the robot and make the robot move in opposite direction. Okay, and then robot will align with the line. Okay, so output from the PAD control is will give to the inward kinematics algorithm. Okay, from this one, okay, one output is will separate into view left and view right. Okay, the output from the PAD control is just the compensating. For the example, if you have the error 5, okay, it might be 5 millimeter or 5 centimeter. Okay, I will assume that it's 5 millimeter. Okay, so when the PD control do that, it will try to compensate the error, right? Okay, if it's got the error around 5 millimeter, okay, PD control will try to estimate the output from that. If you calculate, maybe output will be 10. Okay, because we need to action very fast. Output might be 10. Okay, it's like a greater, and PAD control can check the speed of changing of the error. For the example, if the previous error is a 10, sorry, if the previous error is a 0 and current error is 5 millimeter, it means you have some difference of the error, right? PAD control can estimate. It's like a, okay, you have the error changing. Okay, the output might be different. So this thing is not the same as you did from the programming part, because from the programming part you will use the if else to do that, right? But right now we will use some the mathematics model to make the output for your robot. Okay, not if else. Okay, we use mathematics to control. Okay, for the output we use the inward kinematic to separate two inward kinematic. Okay, and the value that you got is you can separate the speed of the motor left and right, and we will use wheel left and wheel right to control, to put in what to put here. Okay, flow chart continue to here. Okay, we got velocity of the left motor, right? And also the right motor, right? Okay, we just put it in this. Do you remember? This is the from the channel 1 and this from the channel 2. We use this to control what? To control the duty cycle. Duty cycle related to speed of the motor. Do you remember? 100% is means full speed. 50% is mean 50% is mean half of speed. Okay. 50% is my half speed. And 25% is look like this. Yeah. Turn on less than turn off. So this means your motor will move very slow. Okay, we move really slow. Okay, this is the main concept. I will go too deeply in the, I will explain more about the error. Okay, to calculate the error is mean the position. This is a thing that you got from the sensor normalization and the position, maybe in week 11. And our set point is equal to 0, actually, equal to 0, because we need the robot to move to the center of the line. That means actually our set point is a 0, but the error can be positive and negative. Positive might be if your robot is error like on the left, it might be negative. If the robot is error on the right, it might be positive. Okay. And then when you got the error, okay, this is a, I give you the pseudocode. We can call the pseudocode. Okay, you can use this to make your program. Okay, let's focus on this line first. Output the bill. The bill is from the angular velocity. Okay, the bill is from the angular velocity. We have the constant value kp multiply error from here, right? Ki multiply error integral. Kd multiply error derivative. Okay, so the first error, that is the error from actual error. Okay, actual error. And the second one here, error integral. Sorry, I'm wrong something. Uh, Error integral, we have to pass here. Pass equal. Because this is an integrate. Actually, it's from mathematics. Okay, it is an integrate error by dt. Okay, and the second one, error derivative. Okay, is from the error minus error previous. Okay, divided by d3. Okay, I already told you that. What is the dt mean? The loop interval. Okay, if is from the frequency of timer. Okay, it's from the frequency of the timer interrupt. Okay, but the dt is the period. You can convert from the frequency to the period, right? Okay, so if you set the periods of the timer interrupt around maybe 0.01 for 10 milliseconds. Okay, you have to multiply you have to repeat dt with 30.01. Okay, and you remember you have already learned from the programming, everything should be floating, right? Because it is a decimal value. Okay. Okay, from this equation you will got the output. Okay, you will got the output here, and then you can continue with next slide. Okay, you already have the output. This thing will separate, will will divide by the inward kinematics. It will divide the outputs of the angular velocity to be the speed of the motor left and the motor right by this equation. Okay, so this from main program, right? Do you remember? And this is from PAD. And B, I already write for you. Okay, and then you can use to output to set maybe team. Sorry, why is too big? Team CCR1. This one might be CCR2. Okay, it depends on the channel. It depends on the channel. Okay, so right now from the slide that I give you, if you done this, it means you already make the robot complete. The thing that you have to do next is to try to tune some the parameter kp, ki, kd from here. Okay, okay, but this is the relationship between the sensor, the processor, and the last one, the actuator. Okay, use this knowledge to make the robot. Okay, uh the thing that I teach you today is not only for today. You have to back to the previous lecture, week 12, week 11, week 10. Okay, based on the topic that I give you today. Okay, good luck.